this morning, Dion? Ah, I am so sorry. I hope your headache goes away. Good morning, Destiny. Destiny is usually one of our first students to arrive. Dion beat you this morning by just about 30 seconds. Hey, Caitlin. Good morning. Can y'all hear me? I was messing around with my volume. Good morning. We may have a visitor today. We have a new Alva teacher, and she messaged me this morning and said she wanted to join our class today. So her name is Miss Hines. I'll be looking for her to come in, and we'll make sure that we welcome her. But happy Monday before Thanksgiving break. I'm excited about Thanksgiving. Are y'all doing anything special for Thanksgiving? Do y'all travel on Thanksgiving? Destiny, my oldest grandson and I, he's 13, we tried to watch the Venom movie. We didn't know if you still had to pay for it. We kind of figured you did, but I think we ended up watching something for free. But I've heard that that new Venom movie is really, really good. What did you think? Heading to your sister's for Thanksgiving. We're driving from South Alabama to North Alabama. I have also heard that the new King Kong movie is really, really good. But I'll definitely have to watch the new Venom movie. My son went to see the new King Kong movie maybe 2 weeks ago. He said it was really, really good. There must be a sad part because he said I did not cry. He's 26. I did not cry, but it was very sad. So something must happen in the King Kong movie that's sad. And I'm sure I will cry. I can cry. I cried everything. I cry happy cries, sad cries, sentimental cries. I'm a crier. Like I cried all the way through the Olympics, like when people win, and yeah, I do the whole. Yeah, I'm also a happy crier. I have a very tender heart. My husband will be like, "Are you crying again?" Yeah, that's cool. Yeah, we're doing a little bit of traveling. We're going to travel this weekend. We're going to leave Friday after work and drive up to North Alabama and have Thanksgiving with my husband's family. Good morning, Allie. And then we're going to drive back to South Alabama on Monday or Tuesday and then have Thanksgiving with like my daughter and her family and my son-in-law. And hopefully our son is going to join us. He works a lot. He's the one that was telling me about the King Kong movie. He's 26 and he works a lot. And so he doesn't, and he lives 5 hours from where my husband and I live. So he doesn't always get to visit us. Plus he has 4 nieces and nephews from the ages of 5 to 13. And sometimes they get on his nerves, but he's going to try to come. I think he's off since Thanksgiving is on Thursday. I think that's right. I think he's off on Thanksgiving. And then I think he's off on the next day after Thanksgiving. But he doesn't get to take off much. Yep, Thanksgiving is always on a Thursday, sometimes on different dates. I always get that confused. You know how some holidays are always on the same date? And then I don't know. I always feel like Veterans Day is always on a Monday, but I guess that's not true also. Well, all right. Look at everybody. Hey, Hunter.
Good morning.
Good morning, Hunter. How are you?
Good.
Good morning, Logan. And I think I already said good morning, Allie. Awesome. This is a Monday morning. We got to go camping this weekend. We bought a little camper and we went to Gulf State campground and we spent 2 nights. And when we woke up in the morning, we were close enough to the beach that we could hear the beach. It was super, we had to wait. It had to be super quiet to hear it, but you could hear it from the camper. We were about a half a mile from the beach. I have like a turtle nesting area there. And we walked to the beach and just kind of walked along the, the shore and then walked back to our cabin, our campground, to our little camper. I was going to try to find a picture. Did I tell y'all last week we were hoping to buy a little camper? Hey, Jeremiah. Let's see if I can find a picture. Good morning, everybody. I'm going to send some pictures to my Google Drive just a second. I want to show y'all what my husband and I got this weekend. Good morning, guys. Good morning, Matt. Good morning, Xander. Monday morning. Trying to send some pics to my Google Drive and I want to share them with y'all. Hey, Rosario. Good morning. Glad that y'all are here. Good morning, Ardelia. My husband also took some pictures. We have the same Apple ID, and so we have a picture share, or we share all of our pictures. And so, yeah, I'm looking on my camera roll, and I'm like, I didn't take that. And once we get on the same Wi-Fi, usually once we get home, everything I took goes to his camera roll, and everything he took goes to my camera roll. So we share those. So, anyhow. All right, guys. We are. I was telling them earlier, good morning, Kiava, if I'm pronouncing that correctly. That is a very unusually nice name. Good morning, Ariana. Let me pull open my Gmail, my drive. Got about 5 minutes. We are supposed to have, good morning, Nella. We're supposed to have a visitor this morning. We have a new Alva teacher, and she's going to be helping out in some of our math classes. And I was messaging with her earlier. Let's see. Good morning, guys. I am multitasking. Good morning, Sarah. I am trying to share. I was going to share some pictures of, I was trying to figure out. I'll probably just share them this way. I'll share them in a sec. Hey, Isabel. Hey, Logan. Hey, Reagan. Good morning. Good morning. All right, we got about 2 minutes. I'll wait just a second. I was going to show y'all. I think I was telling y'all last week that my husband and I were hoping to get a tiny little camper. Not the tiniest, but we were able to camp this weekend, and I was going to show y'all. Trying to get settled here. I have to sit on one leg. I'm weird. Does anybody else like to sit on just one leg? I know. I'm weird. I can't be still either. Y'all are talking about all kinds of stuff. I have no idea what y'all are talking about. But I'm sure y'all get that. Well, all right, guys, we do have a lesson on 706 today. I do not have any your choice activities because I felt like the unit circle, this was a 2-day assignment that started last week on Thursday and Friday, and there was a quiz. And the unit circle, as far as I know, is not taught until you get to Algebra 2. So I really, really wanted to give my own spill on the unit circle to give you some advice. So I decided sometimes I don't have a choice board for y'all to choose different things. So today, I don't want you to go anywhere else, but just hang with us in the lesson today because I really wanted to make sure that the OLS was clear and to give you some personal advice on how to work problems that deal with a unit circle. So 9:15 has just dinged in. I was looking to see. Good morning, Nisa. Good morning, Tyler. Good morning, EJ. We are so glad that y'all are here. I wanted to share just because I think I told y'all last week. My husband and I got to go camping this weekend. We bought a little camper and I was going to share my pictures. Y'all might not be interested, but I would share this with y'all if we were in person class. So I think this will open up where y'all can see it. So this is our little used camper. It's about 22 feet long and about 8 feet wide. And here we are in the Buc-ee's parking lot in, I guess that would be Foley, Alabama, right there on I-10. I don't know if any of y'all know where Buc-ee's is. It's like you're going to Gulf Shore, so it's still in Alabama. It's on I-10. Here it is when we got to the campground and we set it up. The bed is on this end. It's a little Murphy bed, so it closes up into a little cabinet. And it's got a sink and a shower and a bathroom and a stove and a small refrigerator. And then this is my favorite part. Here I am sitting at the campground, all kicked back, just enjoying the weekend. So we got to spend the night, Friday night and Saturday night there in our new camper. Good morning, Natalia. But anyway, I wanted to share that with you because I think it's important that we talk a little bit about what's going on in our lives. We're going to say a big welcome to Miss Hines. She is a new teacher at Alva, and she's joining us today. She's going to be helping out some of our math students. So welcome, Miss Hines. One of the things that I like to use is, thank you, Sarah. Miss Hines, I don't know if you saw, but we got a new camper. We got it. We picked it up Thursday. I don't know if you got to see my pictures or not. I was telling them about it last week, and we got to camp this weekend at the Gulf State campground and go to a wrestling tournament. Our oldest grandson is 7th grade, so he has first middle school wrestling tournament, and we just kind of made it a camping weekend because they wrestled at Gulf Shores High School. But I was showing them some pictures.
I did. That's awesome.
So it's not new, but it's new to us. And so, we've had a camper once before, but we actually lived in it for like almost 2 years. We sold our house and we were kind of in between trying to decide to move here. So we've camped before, but we haven't ever pulled that small of a camper, which is so much easier than the one that we lived in for a while. Guys, tell Miss Hines in the chat, give her a welcome. Again, she is one of our new teachers. One of the things that I like to use, Miss Hines, is I use something called the whiteboard. It's actually called Whiteboard Fi, but I will always give them a link. It's also in my announcements. So I try to get those set on Friday before the week. So when you go into your OLS, you can see the announcements and it'll say what we're teaching in Monday's whole group. And then it'll have the whiteboard link. And then I'll have a PowerPoint link in case students just want the PowerPoint. And then I also give, it'll have Mondays and Wednesdays lesson with the links that go with the whiteboard and the PowerPoint. And then I also just put them in the chat as we get into class, just because sometimes it's easier for students to grab them. Are you familiar with whiteboard at all?
I have a long time ago. It's been a minute.
So one of the really cool features that I like, it is optional for students. They don't have to log into it, but I can see, I'm sharing my screen right now, so I can see which students have logged in. And if they're going to do the exit ticket, they do have to use the whiteboard link to do the exit ticket. Other than that, they don't have to use it. But I would say, and students can join in here, I would say what I like the most about it is there's a feature called Copy Teacher. So as I work through the examples, they can hit Copy Teacher and all my writing will copy into their whiteboard, and then they can save it at the end. I would say probably a negative is they do have to have an extra tab open, and they can just have my audio up in the neuro session and then they'll have another tab open. I know some students don't like the 2-tab but it does. I try to make the whiteboard, I try to put all the references in it, all the formulas in it, and that's something that they can save and use on their quizzes and their tests. So I do know it's probably been updated. It is something that I have to pay for each year, but I don't get refunded for it. It's not an expense, but it's really worth it to me. And
nice.
I like to use it. So little introduction on that. I will stop talking. Let me remind everybody that we need to concentrate on our lesson today and not flood the chat with things that don't apply to the lesson. So if that happens, guys, you will just be removed from the chat. So make sure that you're paying attention to the lesson today as we go through it. And that's our main goal for today. So Jameis says 706, 701, watch the videos, but don't show that I did. Okay, let me jot that down. Sometimes when we're doing things in the OLS, it checks off and sometimes it doesn't. So I'll check on that, Jameis. I'll write it down. All right, guys, I'm going to warn y'all one more time about the chat before I remove you, okay? Keep your comments in the chat focused on what we're doing today. Okay, let's take a look at our do now. One of the things about the do now is there could be multiple answers. There could be multiple answers. So take a look at the do now. Don't answer yet, but take a look at the do now. and be thinking about which problem does not belong. Be thinking about which problem does not belong. Hey, Tyler. No problem. Here's the link to the whiteboard if you would like to use it. Y'all be looking at that. Do now. Check to see which one you think does not belong. And I'm looking for something now. Give me just a second. Okay. All right. In the chat. So this do now is focused around, let me give you a hint on this if you don't know what it's about. It's focused on when I made it up, when I made this problem up, I was thinking about right triangle trig. Now remember, when you do a problem that says what does not belong, you could think outside the box, inside the box, around the box, inside your head. You can think differently. But if you don't mind answering in the chat, which problem do you think does not belong? Y'all can go ahead and answer in the chat at this time. Which problem do you think does not belong? And I'm going to open this up just a little bit wider. Anybody have an idea? Destiny's guessing D. Anybody else want to tell me? And then we'll kind of go with why y'all think your choice does not belong. I don't know about y'all on Monday mornings, but they're definitely a little bit hard for me. Tyler is just so honest. He says, I don't even know. I love honesty, guys. All right, let's go with Destiny. Destiny, why do you think D does not belong? And I think I made this on my second slide just so we could have a little bit of room for me to write. All right, Destiny is going with D. We've got some alliteration going there. Destiny is going with D. Ardelia also thinks D. Sarah's thinking maybe A. So we've got a couple D's. And we also have a couple people that are saying A. Still sticking with D and A. Can anybody tell me why they chose D or A? I think Sarah said A. Anybody?
I chose A because I noticed that the angle that that's the opposite of whatever angle you have, or sorry, the side that's opposite of whatever angle is labeled. A is the only one where the opposite is actually a number and not a variable.
Excellent. Okay, so let me try to rephrase what Sarah just said to me. She said she chose A. I'll put a box around A because if we go opposite of the angle that's given, not the right angle, but the acute angle, meaning the angle less than 90, if we go opposite, we get a number. Here, if we go opposite, we get a variable. Here, if we go opposite, we get a variable. And here, if we go opposite, we get a variable. So see, I didn't make that problem up for that to be the answer, but excellent. I love that y'all can just see different things, okay? So again, Sarah said she chose A did not belong because it was the only triangle where if we went opposite of the angle given, not the right angle, but the other angle, we were actually given a number and not a variable. Can y'all give me like a yes in the chat if you understood how Sarah saw that problem? Awesome. Good job, Sarah. Anybody else want to tell me why? Excellent job explaining that. Anybody want to tell me why you chose D? If anybody chose D. I'm telling you, there's not just one right answer to these. And that's why I kind of like them. It gets our brain kind of warmed up. It's like stretching before you start running or lifting weights or whatever, riding a bike or whatever you do for exercise. Okay, Tyler says we will not read his negative comment about himself. He says that it's the only one that's upside down. Hey, visually, let me see if I can say that back to Tyler. So here's the right angle. So here's the right angle. Here's the right angle. Here's the right angle. This is kind of how I see it when he said upside down. And y'all see how this triangle is like flipped over and the right angle is up in the top left. Yep. Sarah rephrased it. It said it's the only one where that right angle isn't in the bottom right. Okay, so I did not choose, when I made this problem, I did not choose A or D for the one not to belong. And I love it when y'all do this and you don't pick the one that I actually made to be. I actually made, let me think, I made C for the one not to belong. So let me erase some of my scribbles. Can anybody think why I chose C? Love how y'all chose A and D and explain that. Sarah and Tyler, thank you. Anybody know why I chose C when I actually made the problem? I made C not to belong.
Is it because we know what the hypotenuse is?
Yep, Sarah's got it. It's the only one where we know the hypotenuse. So we don't know the hypotenuse here. We don't know the hypotenuse here. We don't know the hypotenuse here. But in C, that's the only one where we know the side opposite of the right angle, which we do call the hypotenuse. So it would actually be the only problem that we could use. What do you have to have the hypotenuse for? Sine, cosine, or tangent? Y'all remember that? I know I'm digging pretty deep. Sine, you have to know the hypotenuse. Sine is opposite over hypotenuse. And also cosine is adjacent over hypotenuse. So A, if you look at A and B and D, if you don't know the hypotenuse, which trig function out of the sine, cosine, and tangent doesn't have the hypotenuse? I've kind of given you a lot of hints here. Which right triangle trig function? Yep, it would be tangent. Tangent is adjacent over hypotenuse. Oh, no, it's not. I didn't mean hypotenuse. Adjacent. No, it's opposite over adjacent. Sorry. Opposite over adjacent. So C would be the only one that we would not use tangent for. If we were solving A, B, or D, we would have to use tangent because we don't have the hypotenuse. Wow, we came up with like 3 or 4 different ways to look at that problem. Awesome. Thank y'all so much for hanging in there and participating. All right, let's take a look at, this is our week. So it looks a little bit shorter. Today is Monday, Tuesday, and Wednesday. We have 2 sections in Unit 7 that are really, really long. So 706, we took 2 days to do that. That was Thursday and Friday of last week. 708 is also fairly long. So we stretched it out to Tuesday and Wednesday of this week. Thursday will be 709, and then Friday will be a catch-up day before our wonderful Thanksgiving week. And Tyler just commented on the unit circle, and that's why I chose to talk about the unit circle today. You don't have a lot of background knowledge at all with the unit circle. I do think this is the first time in any math class you've ever been taught the unit circle from the beginning to the end. So that is another reason I did not have any choice activities, because I really want y'all to hang in here and us talk about the unit circle, because it should be pretty well a brand new topic for you. Quick reminder, remember we are a mixed whole group. So we have regular Algebra 2 students invited to our whole groups. We have honors Algebra 2 students invited to our whole group. And we also have essentials Algebra 2 students invited to our whole group. I know that's super confusing, but that's the way our schedule was set up this year. So I need to take like 30 seconds and I need to talk to my honors students. So if you're in honors, Algebra 2. Just a reminder that you have a project. So don't freak out. If you're not in honors, this project is not for you. It's only for my honors Algebra 2 students. But you have a project due the day that we return from Thanksgiving break. Okay. Just a quick reminder, I have sent out two separate emails with help videos for your project. And I also held an extra honors project help session last week. If you were not able to attend that session and you're in honors algebra 2, you should be able to go back and watch the recording. But your project is due Monday, December the 2nd. So that's the day that we return from Thanksgiving break. So I wanted to take a minute and remind my honors algebra 2 students that you do have a project. If you have not watched the help videos, or if you have not opened up that project, you need to spend some time this week opening up the project, reading the rubrics. You have a choice between two projects. You can choose project 1 or project 2. And you need to make sure that you have either come to the help session or come to Wednesday's help session, or watch the videos. You need to know what you're doing because that's due. Hey, TJ, that honors project is due the Monday after Thanksgiving break. Now, quick reminder, TGAs, so this honors project would be a TGA. Technically, it's not due until December the 11th. But it actually closes that night at 11:59 p.m. So you would not want to wait because it's a 100-point project and it's a digital project. And if you have any digital links that won't work, you're going to want to make sure that you turn it in way before the due date so I can get you some feedback. It's a pretty big point project. Any quick questions? If you're an honors algebra 2 student, any quick question about your project? Yep, it's 100 points. My advice is to choose the Bitmoji one. If you came to the help session last week, specifically for honors algebra 2 students, we went over a lot of information and y'all asked lots of really good questions. If you weren't able to come to that help session, you might want to watch the recording. Definitely watch my help videos though. All right, guys. Okay, I'm going to go ahead and get started because I have a whole lot to talk about today. Remember, I always include this slide. Since we're a public school in the state of Alabama, I don't get to make up my lessons. I have something called a course of study. Today, we're focusing on a course of study objective 21, and it is mainly focusing on how to use the unit circle to find angles, to solve problems, and that's what we're going to focus on today. Today is 706, Tyler. So today is the unit circle. So this was Thursday and Friday's assignment, but it is 706. Oh, the project that's 100 points. Tyler, are you in honors algebra 2? You are, aren't you? Okay. All right. You're not. Don't worry about it. I know last year our honors had separate whole group sessions than our regular and our essentials. And this year we had so many extra classes that we couldn't fit everything in the schedule. So they just grouped all algebra 2 students together. And I know that can be a little bit confusing. Okay. So I'm not going to spend a lot of time on this slide, but I do want to try to take you back to geometry. I don't know whether you liked, Aaron is saying he cannot see my screen. Can y'all tell me if you can see this right triangle and this right triangle? I'm screen sharing. Thank you. Their suggestion, awesome. Suggestion is to refresh or go back out and come back in. Okay, so I'm not going to spend a lot of time on this slide, but I do want to tell you that the unit circle is built by right triangles that you learned in geometry. So back in your geometry days, and I've seen some of y'all commented, I'll be very transparent with y'all. Geometry is my least favorite math. When I first started teaching, I had 4 geometry classes way back in the day. And I'm like, oh my gosh, I cannot believe they've given me geometry classes. I studied probably harder than anything I've ever studied to teach. just geometry didn't make a whole lot of sense to me. I really think that most students are either geometry minded people or algebra minded people. Most people fall in one camp or the other. There are a few people that are just really, really blessed and they just get this whole entire brain. But sometimes people don't do very well in geometry that do better in algebra. But yes, so really, really quickly, I just want to say that your unit circle is built on the foundation of 30, 60. We studied these in geometry. 30, 60, 90 right triangles. I don't know if anybody happens to remember the 30, 60, 90 right triangle. And then in geometry, we also studied the 45, 45, 90 triangle. And we found out that there were certain relationships between their sides. So that's why you're seeing the side opposite of 30. It's called the short leg. It's X. The side opposite of 60 was called the long leg. It's going to be X times the square root of 3. And then your hypotenuse is always going to have the value of 2 times your X. Not going to get into this. This is the geometry part. But this is kind of how your unit circle is built. And I always like to kind of explain that this is where it comes from. In a 45-45, the leg opposite of each 45 is equal. So for instance, if this was 7 inches, this side would also be 7 inches. And then the side opposite of the right angle, which is your hypotenuse, would be your leg, which would be 7 times the square root of 2. So this side would be 7 square root of 2. I will tell you that these two special right triangles pop up all the time on the ACT, on the pre-ACT. We see these once we get to some college math. We also see them in the next hardest math after Algebra 2, which is pre-cal. So just in case you're wondering where in the heck are all these numbers coming from on the unit circle, the unit circle is built on these two special right triangles that you learned about in geometry. Okay, now to today's lesson, unit circle. So I want to go to this slide. I wish I could have made this unit circle a little bit bigger. I know that you can go to the 3 circles in the top right and you can make your screen bigger. So if you need to do that, you can. I have to be able to see my tools to write on. So I'm going to have to leave it this size. But I want to start with some basic information that you should have learned last week in 704, 705, leading up to 706. So when we look at the unit circle, a lot of people don't even know why it's called a unit circle. So let me explain that part. So if you go, so these are ordered pairs. So if you'll notice right here on the right, I'm going from the origin. So if you think about this as a y-axis and an x-axis, if you go 1 unit to the right, you're at the ordered pair 1, 0. So your radius is 1 unit. So that's why this circle is basically called the unit circle. So it's 1 unit to the right. Look at this ordered pair. 0, 1, 1 unit up, -1, 0, 1 unit to the left, and then 0, -1, 1 unit down. So sometimes when we're studying something that's complicated like the unit circle, we miss the whole point that why is it even called a unit circle? It's called a unit circle because the radius is 1 unit. It might be 1 inch. It might be 1 mile. It doesn't really matter what the specific unit is, but it's 1 unit in each direction. Okay, so that's the first thing I like to bring to your attention when we're looking at the unit circle. I'm going to pop the whiteboard link. I see we have a few people that just joined us. Here's the whiteboard link for today if you would like to use it. Okay, so if we were in person school, I would make you memorize. You would not like me for a while, but then you would like me after you memorized everything on this unit circle. Okay, if you're taking the ACT or if you're in college taking a math class, your teacher is probably going to expect that you know this unit circle. They're not just going to give you a reference sheet and say, here's the unit circle. So I actually start by giving my students a blank unit circle if we were in brick and mortar, in-person school, and we would label everything on the unit circle. And they would study it for probably a week. And then I would give them a blank unit circle and they would have to write everything on it. Okay. You would probably not like me at the beginning, just like I said, but once you memorize it, it helps you understand the unit circle. So let's just kind of go through parts of the unit circle. So do y'all see the 0 degrees? Let me change to a different color. One thing that I think is unusual about the unit circle is as we travel counterclockwise, so as we travel against the clock, the angles increase. So this is 30 degrees. Let's start with the degrees, and then we'll move on to these angles that are called radian measures that have the pi's in them. But this is 30 degrees. This would then give me 45 degrees, 60 degrees, all the way to 90 degrees. So let's just look at all the angles that are marked by degrees. So I'll circle these: 30 degrees, 45 degrees, 60 degrees, 90 degrees. Then it continues, okay? If we're rotating against the clock, which is called counterclockwise, then we rotate again 30 degrees. So that's 90 plus 30, which gives me 120. And then we rotate 15 more degrees. So that's 120. That gives me 135. 15 more degrees. That gives me 150. 30 more degrees. That gives me 180. So if I rotate all the way here, that's 180 degrees, or anywhere in between. So the first thing to me, we got to break this giant circle down and look at angles first, and then we'll look at the ordered pairs. If we continue to rotate, so we're going all the way 180. If we continue to rotate 30 more degrees, that gets us at 210. 15 more degrees, 225, 15 more degrees, 240, 30 more degrees, 270. Then we can continue to rotate. Think about a tire rotating 360 degrees. We use 360 a lot. We use 180 a lot. But if that tire rotates all the way around one time, that's 360 degrees. Have you ever wondered, those of you that drive or those of you that have watched people drive, have you ever wondered how your odometer, I've always heard that pronounced two different ways, how it can tell that you've driven 32 miles? How do y'all think your car knows how many miles you've driven? Have you ever thought about that? How do you think your car knows how many miles you've driven? Is it just guessing? Tyler's thought about it. How do you think your car knows how many miles you've driven? Anybody got an idea on that? And then we just keep going around. 30 more degrees, we're at 330, 15 more degrees, 315, 15 more degrees, 330, 30 more degrees, we're all the way back here at 360. Every rotation, there we go, Jatisha's got it. Every rotation is a circumference of the outside of your tire. So your car is programmed to know how many rotations make 1/10 of a mile, how many rotations make 1/2 of a mile, how many rotations make 1 mile. And as your tires rotate, your car calculates the number of rotations, and then it tells you how many miles you go. Pretty cool. There's a lot of math and a lot of things that we do, but we just, we use it. We just don't, we use what the math does, but we don't always know there's math there. Okay. All right. So that's the first thing I usually show my students. So we go around the circle counterclockwise, and the angles increase from 0 to 360. Okay. Any questions about, do you see how we're going 30 and then 15 and then 15 and then 30 and then 30 and 15 and 15? So it's consecutive the way the angles are marked. Now, the positive thing is in virtual school, you're going to always have, you can Google unit circle and you can always have all these angles. You just have to figure out how to use it. Okay. So I'm going to erase my blue. So we have angles that are measured by degrees, which is what your brain is most used to angles being measured by. And then we also have angles that are measured by radians. So let me change to a different color here. What did I use? Blue. Let me use pink. Okay. So you have, here's 0 degrees with a little circle. This 0 doesn't have a degree, so this is your radian. So here is 0 radians. Pi over 6 is the same as 30 degrees. When we have the pi in the angle measure, we know it's a radian and not a degree. You missed erasing 270. Thank you. I need all the help I can get. All right, so pi over 6 radians is exactly the same as 30 degrees. It's just two different units of measure. And then pi over 4 is the same as 45 degrees. Pi over 3 is the same as 60 degrees. Pi over 2 is the same as 90. And then we're still getting larger, but these are just radian measures. Pi, here's some things that you probably need to know. You really need to know pi is the same as 180. You really need to know pi over 2 is the same as 90. At least it kind of needs to be in there somewhere. As we continue to rotate, 7 pi over 6 radians is the same as 210. 5 pi over 4 is the same as 225. 4 pi over 3 is the same as 240. 3 pi over 2 is the same as 270. I usually make sure my students know that. 5 pi over 3 is the same as 300, excuse me. They don't always know that. 7 pi over 4, 315, 11 pi over 6. And then we finally get to 2 pi, which is the same as 360. So rotating 360 degrees is the same thing as rotating 2 pi. So you're not as familiar with the radian measures, which are the ones with the pi's, the one circled in pink right now, but you'll get more familiar with those as you go through Unit 7. Those are new also. So the concept of degrees, angles being measured by degrees, and then them also being measured as radians. The radian is a new concept also. Okay, one last thing. So we know our angles can be measured in degrees. We know they can also be measured in radians. Let me erase. And then the only other thing that's on this unit circle is, what have I missed? What have I not talked about? What do you see that I've not talked about? We labeled the angles that are measured in degrees. We talked about the labels that are measured in radians, the coordinates, Tyler. So we would need to know the coordinates. So what do we use? Pink, blue, let's use green. So here at 0 degrees or 0 radians, the ordered pair is 1, 0. And then this is where the right triangle trig, those 30, 60, 45, 45, 90, special right triangles. So these are all ordered pairs at different angles. So then you would know these. If you'll notice, these numbers are repeating. So this is 0, 1. This is 1, 0. This is negative 1, 0. This is 0, negative 1. And then a lot of these X's and Y's are repeated. So I don't have like 1,000 different numbers in my ordered pair. I have some of the same numbers. It's because this is built on that 30, 60, and 45, 45 right triangle. The good thing is you don't have to memorize all these ordered pairs. You just have to know how to use them. So we have different ordered pairs at different angles. Okay. Now, how do we use this unit circle? Well, in this golden box, this is extremely important. We know when they're asking us for sine on the unit circle, they're asking us for the y value. We know when they're asking us for cosine on the unit circle, they're asking us for the x value. We're talking about from the ordered pair. So your ordered pair, the first value is always your x, your second value is always your y. When they ask for the tangent, you have to go above and beyond here, and you have to divide your y value by your x value. All right, let's think about that for a minute. Sine is y, cosine is x, tangent is y value divided by x value, all coming from the ordered pair that's at that angle. We can get a little bit more technical, and we can do cosecant, we can do secant, and we can do cotangent. But remember from right triangle trig, cosecant is the inverse of secant. So it's 1 over y. It's 1 divided by y. Secant is the inverse of cosine. So it's 1 over x. Cotangent is the inverse of tangent. It's x over y. I will tell you that you will spend most of your time only doing sine, cosine, and tangent. But I wanted to talk a little bit about cosecant, secant, and cotangent. Okay. Now, I'm going to get into some examples. I've got about 9 minutes. I really wanted to introduce this topic from the very, very beginning, and then I wanted to show you some examples. Positive thing is you don't have to do a lot of work, but you do have to know how to use the unit circle. Okay. So sine is y, cosine is x. If you forget that, let's put them in alphabetical order. Cosine comes before sine, correct? In the alphabet. Cosine comes before sine in the alphabet. X comes before y. X comes before y. Cosine comes before x. So when they're asking you for the cosine, they're asking you for the x value of the ordered pair. When they're asking you for the sine, they're asking you for the y value. So think alphabetical order here. Alphabetical order. All right, let me jump right in. I want to do as many examples as I possibly can. All right, directions are going to say, this is important. Your directions are going to say, solve the following problem. Sometimes they say, use the unit circle. Sometimes they just tell you, hey, go use the unit circle. Sometimes they say exact values. So if they say use the unit circle or they say find the exact value, that also means use the unit circle. We don't want any decimals. So exact value means no decimals. All right, so this is sine at 90. Okay, so you know sine is y. So we're looking for the y value. We go to 90 degrees on the unit circle, and we only want the y value. We know y because it says sine. So the sine at 90 means the y at 90, and that would be 1. So the answer to that one would be 1. I'm going to do a few, okay? These don't take a lot of time. Number 2 says cosine. So in your mind, you know cosine is x. We got to go find the angle pi over 4, which is not degrees, but radians. Pi over 4 is here. It's asking for cosine, which means only the x value. So that's the first value of your ordered pair, and your answer would be square root of 2 over 2. I'm going to do all 4 of these. I'm going to let you just kind of let it sink in. Number 3 says sine. So that's y value at 5 pi over 4. I always spend a lot of time just trying to find 5 pi over 4. 5 pi over 4 is here. We're looking for sine. So that's y only. So that's negative square root of 2 over 2. That's the y value only. So that's just that y value. And the last one is 135. That's in degrees. 135 is here. They're asking for cosine only. So that's your x value. Cosine at 135 is negative square root of 2 over 2. All right, let that sink in. I know I went pretty fast. Find the angle. Cosine is the x value. Find the angle. Sine is the y value. Okay. Questions about those 4. They don't get much easier. Remember, I kind of like to start with the easier problems and progress to the harder problems. Because if you don't understand the easy ones, we got to figure that out first before we get to anything that's harder. Find the angle on the unit circle. Cosine is always your x value. Sine is always your y value. I do have a few tangents, but I didn't want to start with tangents because tangent is y divided by x. It's just a tiny bit harder. Sine is y, cosine is x. Find the angle, and then you find that x or y coordinate. Not seeing anything in the chat. Any questions? And some of you may be, I got that. Hopefully you're going, oh, that's what I was supposed to be doing. Okay. So these directions do not say use the unit circle, but they do say find the exact value. So that means use the unit circle. Exact value again means no decimals. Don't try to use your calculator. So many students just go straight to the calculator. They start typing a bunch of stuff in. I've given the ACT like 1,007 times. You don't know how many times students just sit there punching buttons on their calculator because they really don't know what they're doing. These do not have anything to do with the calculator. There may be some problems in some other sections where you are using your calculator, or maybe some in 706, but a whole lot of stuff in 706 is just being able to read the unit circle. Okay, 7 pi over 4. Cosine, so in my mind, cosine is x. Go find the angle, 7 pi over 4. 7 pi over 4 is right here. Down here in the third quadrant, just a quick reminder, we still have these same quadrants, first, second, third, and fourth, just like we would on a coordinate plane, and we're doing x. This, the first value is your x, and that would be square root of 2 over 2. Number 6, wanted to do a negative angle. Wanted to do a negative angle here. Okay, does anybody know what to do if your angle is negative? What do we do if your angle is negative? I've not talked one time today about a negative angle. Did anybody learn this? Has anybody already gone through 706? Do you know what to do when it says negative 30? It's not going to be this 30 because that's positive 30. That's your positive 30. Tyler says you take the opposite of each coordinate. I think that might work sometimes, Tyler, but I don't think it's going to work every single time. So let me just show you how I was taught. So if we rotate counterclockwise to get to positive 30, then we rotate clockwise to get to negative 30. So this angle that's 330, if we go all the way around counterclockwise, it's also negative 30 degrees. So rotating this way is positive. So rotating against the clock is positive rotation. Rotating with the clock is negative rotation, which is opposite in my brain. You would think if we go like the clock, it would be positive. And if we go against the clock, it would be negative. But that's the opposite of how the unit circle is labeled. So if you go down, that's negative. So if you go up to positive 30, always look at where the positive is, and then I go look at where the negative is. So if I rotate this way, that's positive 30. If I rotate, that's against the clock. If I rotate with the clock, that's negative 30. And so we're looking for the sign, which is the y value, and that's negative 1/2. So let's go back to the comment, take the opposite of both. If I took the opposite of the x and the y, it would make them both negative, which is not true. Because if you go from the first quadrant to the fourth quadrant, the x value is still positive. So that's why I had to think about that question for just a second. So I would just think, okay, where's positive 30? And I would rotate clockwise the same amount to get to negative 30. All right, let's do this one. Let's do negative 2 pi over 3, a little bit harder because it's radians and not degrees. It's going to be harder on our brain to do radians. But I would find positive 2 pi over 3. So look, you would rotate all the way here to get positive 2 pi over 3. So that's more than 90. So that means you're going to have to rotate all the way to here to get to negative 2 pi over 3. This is where it starts to get more confusing. Again, we're looking for the sign. So that means the y value only. So we're looking for this value right here. Negative square root of 3 over 2. Okay, I'm at 9:59. Questions about 5, 6, or 7, and then let me kind of look at what we have left as far as what's in my deck, what's in my PowerPoint. So we did have to talk about negative angles here. So when you're doing a negative angle, you're rotating with the clock. If you're rotating with a positive angle, you're rotating against the clock. Okay. All right, I have one more slide. This is talking about angles that are bigger than 360. So I definitely want to talk just a little bit about number 8, and then I will kind of close it up. But if you have an angle that's larger than 360, so larger than 360 or larger than 2 pi. So remember, 2 pi is the same as 360. What I do is I take 600, if it's degrees, I subtract 360, and I try to find an angle that's on my unit circle. There's not going to be any angle larger than 600. So if I subtract one full rotation, I've not changed the location of my angle. So I just keep subtracting 360 until I find an angle that's actually on the unit circle. So 240 is on the unit circle. So I'm going to think about this problem as being cosine at 240. So I subtract 360 if it's a degree angle until I get an angle that's on the unit circle. You stop when you find an angle that's between 0 and 360, Isaiah. Great question. You have to have an angle that's somewhere between 0 and 360 or between 0 and 2 pi, because those are the only angles that are on your unit circle. Sometimes you have to subtract 360 twice. So if I had something like 800, I would have to subtract 360 and then subtract 360 again until I found an angle on my unit circle. So you're just going to keep subtracting 360 until you find an angle between 0 and 360. So let's look at this really quick. 240, here you are, 240. We're doing cosine, which is x. So that's -1/2. You would do the same thing if you were in radians, except you would take, this is 4.5 pi. 9/2 is the same as 4.5. 9/2 confuses me, so I have to think about it as a mixed number. So you would subtract 2 pi, because we're doing radians, until you got an angle that's between 0 and 2 pi. So I'd have to go all the way till I got 1/2 pi, which is the same as pi over 2. And then we do sine, which is your y. So y only would be 1. So this one would be 1. Sine at pi over 2 would be 1. All right, I'm going to stop because I'm out of time and I know y'all have other things to go to. Simplify, Tyler. So basically, subtract 360 if it's a degree until you get an angle between 0 and 360. Subtract 2 pi until you get an angle between 0 and 2 pi if you're given a radian. Real quick, can y'all give me a 1, a 2, or a 3? 1, I got this lesson. Or a decimal in between. 2, I'm almost there, but not quite. 3, I don't understand this at all. Hopefully something made more sense to you throughout the lesson than it did when you entered the lesson today. Thank you so much for your feedback. There is an exit ticket. These are bonus points. This is a you try. I lied. Just a second. Don't forget to save your whiteboard if you're using a whiteboard today. And then your exit ticket is multiple choice. It's asking you to find 4 pi over 3 on your unit circle. And then you're just going to check one of these 4 answers. What would be the ordered pair at -4 pi over 3? And then you would write your answer on this slide of your exit ticket and just leave it there. And then I can go back and see everybody's exit ticket. Y'all have a wonderful day. Honor students, please don't forget that honors project is due the Monday after you come back from Thanksgiving week. If you have any questions, please go back, find my emails, watch those help videos that I sent out. Email me if you have questions, and come to the optional help session on Wednesday if you're needing some extra help. But y'all have a great day. Thanks for coming. I'll hang around for a little bit in case anybody needs. Destiny, did you figure out the exit ticket? I'm just now seeing your comment in the private chat. You'll just answer the exit ticket on this slide, which is slide 13. Yeah, make sure that you answer it on your exit ticket so I can see everybody that's on their exit ticket. You got to leave your exit ticket open. You don't have to submit it. I'll put the link to the whiteboard in one more time in case anybody wants to do the exit ticket. All right, I'm going to hang around for just a little bit. If you have any questions about anything, I'll hang around for about maybe 5 more minutes. But y'all have a great Monday. Thank you so much for coming. Caitlin, Kiava, Nella, Nisa, Natalia, do y'all need anything before I close this out for today? Thank you, Natalia. Anybody else? All right, guys, I'm going to head on out. I have a 10:15 class. I need to get that started. If y'all need anything at all, please don't hesitate to send me an email, and I'll be glad to help you in any way. Y'all have a great day.